Before the first shot is fired, before the first bomb falls, before anyone even knows a battle has begun, something else is already listening. Not a soldier, not a ship, not a pilot scanning the sky. A pulse. It leaves a metal tower on a quiet coastline, travels into the dark, and waits for the world to answer back. Most of the men who would later fight and die in the Second World War never knew that this question was being asked on their behalf. They would remember the war's noise. Engines, explosions, orders shouted into the wind. But long before the noise, there was silence. And inside that silence, radar was already at work. In the early 1930s, Britain was afraid of something it could not yet see. The memory of German bombers over London in the First World War still lingered, and new aircraft were faster, higher, and capable of reaching cities before defenses could react. The British Air Ministry wanted a miracle. What they received instead was a physics experiment. Robert Watson Watt, a radio engineer, was not trying to invent a weapon. He was trying to answer a simple question. Could radio waves detect an aircraft in the sky? In 1935, on a muddy field near Daventry, he proved that they could. The result did not look like a revolution. There was no explosion, no cheering crowd. Just a blip on a screen that moved when a bomber flew past. But that moving dot would change the way wars were fought. By 1939, a quiet line of tall steel towers stretched along Britain's eastern and southern coasts. They were called the Shane Home System. To most civilians, they looked like strange radio masts. To the Royal Air Force, they were a pair of eyes that never blinked. When German bombers lifted off from airfields in France, radar operators saw them first. Not when they crossed the coast, not when sirens wailed, but when they were still forming in the sky across the channel. Fighter squadrons did not have to guess where to go. They were guided, calmly and precisely, toward targets they could not yet see. The Battle of Britain is often remembered as a duel of pilots and planes, Spitfires against Messerschmitts, courage against courage. But behind every scramble order, behind every interception, there was a woman or a man in a dark room staring at a glowing screen, turning invisible waves into decisions that saved cities. Radar did not fire a single bullet. It did something quieter. It gave time. Radar did not stay on the cliffs of Britain for long. Across the Atlantic, in quiet laboratories and naval yards, the same invisible question was being asked again and again. What if a ship could see in the dark? What if the ocean, which had always hidden enemies in fog and night, could be made transparent? The United States Navy took the idea seriously after watching Europe burn. By 1940, American engineers at the Naval Research Laboratory were fitting early radar sets onto destroyers and cruisers. The equipment was crude by later standards, bulky antennas, green glowing screens. Operators who had to learn, almost by instinct, what a real contact looked like and what was just noise. But even imperfect vision was better than blindness. In the Pacific, night had always favored the attacker. Japanese naval doctrine trained crews to fight in darkness, to launch torpedoes and vanish before an enemy could react. For decades, that skill had been untouchable. Radar touched it. At the Battle of Cape Esperance in October 1942, American ships detected a Japanese force before visual contact was possible. Orders were given in calm voices over headsets. Guns were trained on coordinates that existed only as numbers and faint blips. When the first shells landed, the night belonged to the side that could see without light. In the Atlantic, radar fought a quieter war. German U-boats hunted in packs, surfacing at night to recharge batteries and attack convoys under cover of darkness. For months, the ocean seemed to favor the submarine. Then, Allied aircraft began carrying radar sets of their own. A U-boat, even on the surface, could no longer hide in black water. Patrol plane could find it from miles away, guided not by moonlight, but by reflected radio waves. Depth charges followed. Then more radar. Then more aircraft. The ocean slowly became hostile to the hunter. What made radar powerful was not just the machine itself, it was the system built around it. Operators, plotters, commanders, pilots, gunners. A chain of human hands turning invisible signals into movement, and movement into survival. Most of them never fired a weapon. Many never saw the enemy. They listened. They measured. They spoke coordinates into microphones and trusted that somewhere, someone else would act on their words. In war, that kind of trust can be the difference between a ship that returns home and one that becomes a name on a list. Radar did not make war cleaner. It made it faster. And in a war measured in minutes and miles, speed was its own kind of mercy. In the air, radar changed something even more fragile than ships or cities. It changed confidence. Before radar, a night fighter pilot was mostly alone with the dark. Clouds erased the ground. The horizon disappeared. An enemy bomber could pass within a mile and never be seen. Searchlights tried to cut holes in the sky, but light was clumsy and slow. Radar was quiet and patient. By 1941, Britain had begun fitting airborne interception radar into its night fighters. The sets were heavy. Antennas stuck out from the noses of planes like strange metal whiskers. The screens were small and dim, glowing green in the cockpit. A pilot could not fly by them alone. He needed a second person. So a new role was born, the radar operator. 2 men in a narrow cockpit. One watched the sky. The other watched a screen that showed a world made of curves and echoes. Turn left. Steady. Hold. Not shouted. Not rushed. Just spoken into a headset, guiding a plane towards something neither of them could yet see. When the distance closed, when the blip grew brighter, the pilot would finally spot a dark shape against darker clouds. Only then did the guns come out. Over Germany, the system reversed. The Luftwaffe built its own radar network, the Comhuber line, a chain of detection zones stretching across occupied Europe. Each zone had radars, searchlights, and fighters waiting to be directed toward incoming bombers. For a time, it worked. RAF bombers were caught in corridors of light and fire, guided into traps by operators who never left the ground. So the Allies did what radar had taught them to do. They built a system. They sent waves of bombers in concentrated streams, overwhelming individual radar zones. They dropped strips of aluminum foil, called window, which filled German screens with thousands of false echoes. The invisible battlefield became crowded with ghosts. Radar was no longer just about seeing. It was about deception. By 1943, the war in the air had become a contest of signals and counter-signals, new frequencies, better antennas, faster interpretation. The men in the cockpit still risked their lives, but behind them, far from the flak and fire, engineers and operators fought a parallel war with equations and timing. Most history books remember the pilots' names. Few remember the voices that guided them through the dark. A war can be loud and still be decided by whispers. Radar did not only look for enemies. It learned how to look at the world itself. As Allied planners began to think seriously about returning to Western Europe, they faced a problem that no number of tanks or soldiers could solve. They needed to know the shape of a coastline they had not stood on in years, where the water was deep, where sand would hold a vehicle, where cliffs would break a formation before the enemy ever fired a shot. So aircraft began flying strange, lonely missions over the Channel and the French coast. They were not dropping bombs. They were sending pulses. By measuring how radar waves bounced back from the shoreline, from shareline, from fields, from towns, and from water, analysts could build rough electronic maps of Normandy. The land became a pattern of echoes. Bright returns for cities and cliffs. Soft, fading ones for beaches and open ground. It was not a photograph. It was a shadow of a place that thousands of men would soon run across. At sea, radar changed the way fleets moved. In earlier wars, ships had to stay close enough to see each other. Fog could break a formation apart. Night could turn a fleet into scattered silhouettes. Now, ships could spread out, covering more water, still linked by screens and radio calls. An admiral could see his force even when the ocean hid it from his eyes. This mattered most in the Pacific. Carrier battles were often fought by ships that never saw each other at all. Aircraft found the enemy. Radar found the aircraft. Orders moved from screen to deck, from deck to cockpit, from cockpit to sky. The battlefield stretched across hundreds of miles of water and air, connected by invisible lines of information. During the invasion of Sicily and later at Normandy, radar-guided ships stood offshore at night, tracking aircraft and small craft that tried to slip through the darkness. Landing forces moved under a protective umbrella of signals that warned of incoming threats long before they became visible. For the soldiers on the beaches, the war was sand, water, and fire. For the men and women behind the screens, it was geometry, angles, distances, speeds, two versions of the same moment happening at once. Radar did not replace courage. It changed where courage was needed. Sometimes it was no longer in the charge, but in the patience to stare at a screen for hours, knowing that if you missed one moving dot, a ship, a plane, or 1,000 lives might pay for it. By 1944, radar was no longer a curiosity. It was routine. New recruits learned it the way older generations had learned how to clean a rifle. Antennas rose from ships like masts. Aircraft carried radar as naturally as they carried fuel. Command rooms glowed with screens that never went dark. The war had grown a nervous system. In the skies over Germany, Allied bombers flew with radar navigators who could guide formations even when cloud cover erased the ground below. Cities appeared not as streets and rivers, but as clusters of returns on a scope. Rivers drew thin, dark lines through bright patches of urban echo. Coastlines curved like faint fingerprints. Bombing, for better or worse, no longer depended entirely on clear weather or daylight. At sea, the U-boat war tilted decisively. German submarines still slipped beneath the waves, still fired torpedoes, still vanished into the depths. But the surface, once their hunting ground, became a trap. Allied ships and aircraft worked together, their radars overlapping like nets. High-frequency direction finding tracked radio transmissions. Radar found the boat when it surfaced. Sonar followed it underwater. The ocean, which had once hidden everything, now remembered. Even the Germans, who had been among the first to explore radar's potential, struggled to keep pace. New countermeasures appeared. Radar warning receivers alerted crews when they were being painted by enemy signals. Stealth coatings were tested. Tactics shifted again. But the rhythm of the war had changed. Radar favored the side that could produce more sets, train more operators, and integrate information faster across larger systems. This was not a duel anymore. It was logistics of knowledge. In the Pacific, the final carrier battles unfolded under a sky filled with signals. Radar picket ships warned of incoming aircraft. Fighters were launched based on blips, not sightings. Entire air battles were planned and fought before the opposing pilots ever saw each other. The first moment of contact was no longer visual. It was electronic. For the men flying and sailing, this could feel strange. The enemy became something you knew about before you felt. A threat that existed first as a shape on glass, then as a shadow in the sky, and only finally as a plane or ship you could point at. War had gained a new layer of distance. Not just miles, but abstraction. And yet, when a blip disappeared, when a dot faded from a screen, it still meant the same thing it always had. Someone, somewhere, was not coming back. When the guns finally began to fall silent, radar did not. The towers stayed standing. The screens stayed lit. The people who had learned to listen to echoes did not forget how. In the years after 1945, the world was full of machines that had been built for survival and now needed a new purpose. Radar found one almost immediately. Airports used it to guide civilian aircraft through fog and storm. Controllers watched dots move across their scopes and gave calm instructions to pilots carrying families instead of bombs. The same technology that had once hunted night fighters now helped a plane land safely in rain and cloud. At sea, merchant ships adopted radar as naturally as they adopted radios. Harbors became easier to enter. Collisions became rarer. The ocean, which had taken so many lives in the war, became a little less indifferent. Weather services began to use radar to watch storms form and move. Rain showed itself as patterns of return. Hurricanes could be tracked before they arrived. Warnings could be issued hours, sometimes days, in advance. The invisible waves that once searched for enemies now searched for danger of a different kind. Most people never noticed. They boarded planes. They checked forecasts. They drove across bridges in fog. They slept through storms that had been seen long before the first drop of rain hit the ground. Radar became ordinary. And in becoming ordinary, it became invisible again. History tends to remember the loud things, the battles, the speeches, the flags raised over ruins. It rarely remembers the quiet rooms where people stared at glowing screens and decided where to send others into the dark. Radar did not win the war by itself, but it changed how the war was fought, minute by minute, mile by mile, decision by decision. It gave time where there had been surprise, direction where there had been guesswork, connection where there had been isolation. The soldiers and sailors who came home told stories of noise and fear and speed. The operators told stories of patience, of waiting for a dot to move, of listening for a return that meant something was out there, somewhere, and that what they did next mattered. Today, the pulses are still leaving towers and antennas and satellites, still asking the world to answer back. Most of us never hear the question. We just live inside the quiet, invisible space it created,